Now, in this video, let's talk about the circuit connections. Now, when we talk about circuit connections, there are two types of connections. They could either be connected in series, whereby it is one after another on the same conductor like this, or they can be in parallel, whereby there's a division here, there's a split, and there's another path that the current can take and another path that the current can take. Now, remember that current will always try to find the easiest path to go through. So maybe let's say that if R1, if the first resistor was to be broken, our current will still flow, but all of it will now move to flow through this direction of R2. It will now come and move this direction and avoid this path whereby there's a broken element and it cannot flow on that side. So it will keep flowing now in this direction, or if R2 flows, it will avoid this path of R2 and move to the path of R1. Now, in a series connection, however, if one element breaks, if resistor 3 breaks, then the current will no longer flow through the circuit because there's no alternative path for it to take. It only has one path, and that path has a broken element and it cannot flow through there. But always remember that it will always move through the easiest path. It will also always try to move through the easiest path. So if this resistor has less resistance than this, more current will move in that path. Now, what you notice here is that all the current in the circuit, in this series circuit, it moves through only one path. So all of it will go through this one path here. So if we have a current at R3 as 5 amperes, the current at R2 will also be 5 amperes, and the current at R1 will also be 5 amperes. Let's note that down. Now, in a series connection, I1, the current at 1 will be equal to the current at 2 equal to the current at 3. They are all equal because this current only has one path to flow through. However, though, in a parallel circuit, this current will have two options here. It will either move through this path, or it will either come into this path of R2. Now, because of this split, this, depending on the voltage that is in here and the voltage that is the resistance in here. Remember, with Ohm's law, we said that these three have a relationship that looks like this. Now, depending on what the voltage and resistance is, the current on these two paths will be different. So to find the total current, let's use I. The total current, remember this is an ammeter that measures the current. To find this the current of this ammeter, which is the total, because even if they split, remember it goes from positive to negative. So our flow will be in this direction. Now, as it flows like this, as it flows in this direction, when it reaches here, it will have two options, two paths to take. Remember, this is not a path. This is just us connecting a voltmeter. Remember, a voltmeter is connected in parallel to so that we can measure the potential difference between 2 points. Now, as it reaches here and it has options of two paths, you will have a certain value at A1, a certain value at A2. But when it reaches this side, it comes back again, and then the total is now flowing until it gets here. Now, maybe I should put this there. Now, this R3, which is the total, will be the combination of I1 and I2. The current here at the first ammeter and the current at the, so we call this, we say that parallel connections are current dividers, because when it reaches this point, it will divide the current into two. Maybe if you have a third connection, it will divide the current into three. So when you combine all those current, you get the total current, which is the current of this one, because you see that this path, all of the current will pass through here, but it will divide in these two paths. So we call the parallel resistors in parallel current dividers, and the total current will be the sum of all the measurements on the ammeters that you have, even if you have more. But in here, the current will be the same at all three resistors. Now, on the same path, however, we happen to have connect 3 voltmeters to the 3 resistors, which means that depending on the resistance of R1, V1 will have its own value, right? And V2 will have its own value, and V3 will have its own value depending on the value of R3. Now, in series, this potential difference will have 3 unique values. We can connect a bigger one here if we want. If we want for us to calculate the total of the circuit, because you can see it encompasses everything between the 2 points. Remember, potential difference, we measure it between 2 points. So V4, or the total potential difference, will be given by V1 plus V2 plus V3. And just like here, when we start to add stuff, we know that means they have been divided. And a series, resistors that are connected in series, we call them voltage dividers or potential difference dividers, because they divide it into portions here, V1, V2, V3. And then the way I connected V4, it means it measures everything in between these 2 points, right? Now, resistance in series are potential difference dividers, potential dividers, and resistors in parallel are current dividers. Now, here, V1 and V2. V1 will be equal to V2. If there was a third one, we'll say they are equal to V3, as long as those resistors are parallel. Now, the voltage that goes through each resistor will be different, will be the same if they are connected in parallel. So this will, depending on the current and the resistance, you will get V1, which will be the same. Remember that this will be divided, so it will be adjusted to accommodate how much resistance or voltage we have. And the way we connected this larger V3 encompasses everything. Therefore, it calculates the total. So V1 and V2 will be the same. Now, Another interesting thing, now that we have the current, we know how to find the current, we know how to find the voltage, we know how to find the current in parallel, how to find how the voltage is divided, the current is divided, and how the voltage is in a parallel. Let's now talk about the resistance. Now, in a parallel, in a series connection like this, you have R1, R2, R3. It's pretty clear to see that to find the total resistance, which is the total resistance, we're just gonna take R1, add R2, and add R3. So R1 plus R2 plus R3. You see, because they're in series, the total resistance will be the sum of these three resistors. And remember that resistance is measured in ohms, while voltage is measured in volts and current is measured in amperes. So once you have the total here, we can use the total amperes, the total current here, and the total voltage there, and work with the use Ohm law to figure out the relationship. Now, in each case, R3, V3, we can use this to find I3, and we'll find that it is the same in series. Current is the same in series. Now, in a parallel connection though, our total resistance, because it is parallel, we'll find an inverse here and say 1 over resistor 1 plus 1 over resistor 2. Now, because of parallel, the resistors are not the same. Even if we put the same type of resistor, then they will be the same. But to find, even if they are the same, to find the total, we will have to add them. But because they are connected in parallel, we will calculate them using this formula. And then once you add them, and then you can invert. Now, when we look at the Ohm's law again, remember that this is Ohm's law. Ohm's law. Let's look at this relationship again. Now, if we add more resistors, if we keep the same cells here, positive, negative, it goes in this direction, from positive terminal to negative. So our current will flow clockwise for this problem. Now, if we keep adding more resistors, let's say we add more resistors, so the resistance increases. We can see that the current, it is inversely proportional to the current. The current is inversely proportional to the resistance. So if we keep adding more resistors, the current will decrease. The current will decrease as we add more resistors. Now, with parallel connections, if we have our resistance inversely proportional to current, if we keep adding them in parallel, meaning that we increase these denominators, we'll see that the more we add, the value of the total resistance will go down. Therefore, the current will go up. And that's the difference between a circuit connected in series and a circuit connected in parallel. Now, always remember that this resistor, we could put a light bulb, we could put a rheostat, it doesn't matter. They will work in the same way. And those are the fundamental differences between a parallel connection and a series connection. In the video, we will start to play with some examples.